Yeah, g'day. My name's Josh B, and the guy walking backwards with the camera is Daniel Smythe. Today we're going to give you a brief overview of the key things to consider when specifying pipe materials in class. In particular, we'll be covering why this topic matters, some essential information, compromises, and where you can find some further information. So why does this topic matter? Firstly, a key reason is that we don't want our pipe blow our pipelines up. This can be dangerous, economically damaging. It can have negative effects on people's health because they won't be able to get water to the key services they need. And mainly, it's just bloody embarrassing. Another key reason is that you don't want to start your new job as a graduate engineer and ring up a pipe supplier and ask what pipe you want, and they ask you what class you need, and you have absolutely no idea what they're talking about. So essentially, this topic's important because it will just save you some embarrassment in the future.
One of the key things to consider when specifying our pressure pipe material in class is the fluid characteristics and the fluid within the pipe. Some of these important fluid characteristics include our fluid properties, our velocity, our pressure, and what the temperature range is that the fluid will be. Secondly, it's important to consider the local environment of the system when specifying the pressure pipe material in class. Where the pipe is installed is essentially what we mean. Whether it's above ground or under the ground, this gives us an indication to what the temperature of the pipe will be, so what the temperature the pipe will be experiencing, if there's any size restrictions, and it'll tell us how durable the pipe needs to be, if it needs corrosion protection or UV protection. Lastly is the material strengths. There are 8 common materials in New Zealand, each of which have their own different pros and cons, so it's super important to consider these when we do our designs.
The table shown here has a breakdown of the 8 materials and the common properties. The table shows what materials work best for different scenarios. For example, if a durable material is required for a harsh local environment, polypropylene should be ruled out, while copper and cross-linked polyethylene would also be ruled out if the material had to be cheap and durable. Throughout New Zealand, these materials have common uses. Copper is good for cold potable water, polybutylene is used for hot and cold water, polyethylene is used for cold potable or wastewater, and there is various other uses as shown by the table to my left.
Pipe classes are a group of pipes that are specified with respect to their base material, pressure and temperature ranges. When it comes to classifying pipes, it's important to know that there are 3 types of pipe class in New Zealand. There's SN, PN and SDR. SN is the stiffness rating for the type of for gravity-fed pipes that operate under low pressures. These are typically the sorts of pipes that are attached to the end of your sinks and your bathrooms. Whereas SDR is the standard dimensions ratio that relates pipes' durability against pressure. SDR describes the relationship between the pipe's dimensions and the thickness of the pipe wall. When it comes to interpreting an SDR, the lower the number, the higher the pressure that the pipe can withstand. The PN, that's our pressure rating. For pipes with pressurized flow, when interpreting a PN rating, the higher the number, the higher the pressure that the pipe can withstand. This is because a PN provides an approximation for the number of bars of pressure that the pipe can handle. It can be seen in the Marley technical manual for gravity-fed lines with a pipe material of PVC. The pipe is rated with a stiffness rating of SN. When specifying a pipe class for a pressurized system, like what we're trying to do here, with a material like polyethylene, the pipes are rated in terms of PN and SDR. The operating pressure can be used to determine the required PN for the pipe. Once the PN is determined, the designer can use the Barlow formula to check the pipe to ensure that it's not going to break.
When specifying pipe pressure material in class, the biggest compromises are to do with performance, economics and durability. When pipe systems are designed to meet a design life, the pipe is being designed to meet a minimum standard. This is solely for the purpose of designing the durability of the pipe for the economics of the project. Pipe systems are also designed to meet a minimum performance criteria. Once again, this is done in an attempt to reduce performance and to save costs of the project. Finally, we'd like to leave you with some extra information in case you actually want to use any of the stuff we've just talked about. For example, there is the Marley polyethylene systems and other technical manuals that are around that feel free to get them online.